Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here. Maybe you had a long day, or maybe you're the kind of person who likes falling asleep to deep thoughts and cosmic mysteries, rather than counting sheep. Either way, tonight's journey is for you. You've got nothing to do but rest. Let your mind relax, your breathing slow, and your body grow light, as if gravity itself has softened. Because tonight, we aren't simply stargazing. We're drifting through our home galaxy, the Milky Way, a vast spiral of stars, dust, and dark matter, turning slowly in space for over 13 billion years. But beneath its beauty lie secrets, rogue stars, invisible forces, and ancient remains that defy what we thought we knew. We'll travel gently from its spiral arms to its secretive hidden core, from colossal collisions to stars older than the galaxy itself. You'll hear of black holes and stellar nurseries, and the strange, unfinished story of a galaxy still growing. Some of what you hear tonight may surprise you, or at the very least, spark some curiosity as you drift off to sleep. And just before we begin, if these calm, curious explorations help you unwind or give you a quiet way to end your day, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now, let's begin. The Milky Way has already collided with other galaxies, and it will again. Our galaxy may feel like a stable home, but it is built from the wreckage of others. Over billions of years, the Milky Way has absorbed smaller galaxies, drawing them in, unraveling them, and scattering their stars into tidal streams that wrap around the disk. One such galaxy, the Sagittarius Dwarf, is being pulled apart right now. And far off in the night sky, Andromeda is drifting slowly closer. In about 4.5 billion years, the two great spirals will merge in a cosmic collision. Stars will almost never hit each other, but the galaxy's shapes will change forever, folding into a new form, vast and quiet. Even galaxies are not eternal. They evolve, collide, and begin again. Some stars in the Milky Way are older than the Milky Way itself. Not every star in the Milky Way was born here. Some halo stars, ancient, metal-poor, and wandering in long, tilted orbits, appear to have formed even before the Milky Way had fully taken shape. Astronomers believe these stars may have originated in smaller, primordial galaxies that merged with our own billions of years ago. Their chemical fingerprints show almost no heavy elements, suggesting they were born shortly after the Big Bang. They move slowly and high above the galactic plane, like elder spirits from a time before spirals, before order. In their light, we glimpse a universe that was younger, wilder, and still learning to become what it is. Our solar system orbits the center of the Milky Way at over 828,000 kilometers per hour. That's more than 230 kilometers every second. And still, it takes about 225 million years to complete just one loop around the galaxy. This path is called a galactic year. In Earth time, we've only gone around the Milky Way about 20 times since the solar system formed. When the first dinosaurs appeared, we were in a different part of the galaxy entirely. The stars we see today weren't always nearby, and won't always remain. Everything is in motion, quietly, slowly, endlessly. Even as we sleep, the Earth turns, the Moon circles, and the entire solar system sweeps forward through a galaxy in motion. The galaxy is still growing. Although the Milky Way is ancient, it isn't finished. Even now, it continues to gather material, gas from the intergalactic medium, stars from captured dwarf galaxies, and streams of dark matter that feed its halo. It grows not like a living thing, but like a gravitational structure deepening over time. Some of this growth happens quietly, through infilling clouds. Other times it comes with disruption, as satellite galaxies are torn apart and their stars scattered across the sky. The galaxy you live in today is not the same one the dinosaurs saw, and the one your distant descendants may know could be larger still, stitched from the ruins of 1,000 smaller worlds. We don't know how many arms the Milky Way has. It seems like something we should know, how many arms spiral from the center of our own galaxy. But from our position deep inside the disk, it's hard to see the whole structure. Dust clouds obscure distant regions. Stars blur into one another. For decades, astronomers believed there were 4 major spiral arms. More recent observations suggested maybe fewer, or that the arms twist and split in ways more complex than expected. Some fade into fragments, others wrap around unexpectedly. The Milky Way may not be a neat pinwheel at all, but a living, layered swirl of stars shaped by forces we still don't fully understand. Rogue stars are flung from the core. Most stars drift calmly through the galaxy, but a rare few are flung outward at astonishing speeds, fast enough to escape the Milky Way entirely. These are hypervelocity stars. Some are the remnants of binary systems disrupted by the supermassive black hole at the center of the galaxy. One star falls in and vanishes. The other is slingshotted outward, hurled into the dark at over 1 million kilometers per hour. These rogue stars travel alone, far from the galactic plane, like glowing comets with no return. They remind us that even in a galaxy bound by gravity, there are moments of violent release, quiet expulsions that send stars flying into intergalactic night. The Milky Way and Andromeda are on a collision course. High above the horizon, the Andromeda galaxy appears as a faint blur to the naked eye, a spiral much like our own, lying over 2 million light-years away. And yet, it is moving steadily toward us. In about 4.5 billion years, the Milky Way and Andromeda will collide. It won't be violent in the way you might imagine. Stars are spaced too far apart to crash directly. But their gravity will warp both galaxies into long, stretching arcs. Tidal tails will curl outward. Black holes may spiral together. And after billions of years, the two galaxies will merge into a single, larger system. It will be a slow, elegant dance, the future of our home written across the stars. Some stars orbit backward. Most stars in the Milky Way orbit the center in the same general direction. But not all follow the rules. Some stars, especially in the outer halo, move in retrograde, orbiting opposite to the galaxy's main rotation. These stars likely arrived from elsewhere, born in dwarf galaxies that were later absorbed. Their reversed motion is a quiet signature of their foreign origin. It's as if the galaxy carries old memories in its motion, stories of ancient mergers and cosmic encounters, preserved not in light, but in the slow, patient turning of stars against the stream. The Milky Way may have eaten dozens of dwarf galaxies. Over billions of years, the Milky Way has not grown alone. It has consumed. Small galaxies, faint, Lomas companions, have drifted close, been caught in its gravity, and slowly dismantled. Their stars are now part of our halo, disk, or stellar streams. Astronomers have identified several of these mergers by analyzing stellar motion and composition. One especially large event, the Gia-Enceladus merger, added many stars and may have reshaped the early structure of the galaxy. The Milky Way is not a pristine spiral. It is a composite, built from quiet collisions, stitched together from the remains of many smaller worlds. The chemical makeup of stars reveals their origin. Every star carries a unique chemical fingerprint, a pattern of elements imprinted at birth. By studying these signatures, astronomers can trace a star's history. Some stars are rich in heavy elements like iron and calcium, suggesting they formed in dense, metal-rich regions. Others are nearly pure hydrogen and helium, born when the universe was still young. These differences allow scientists to group stars into families, uncover ancient mergers, and reconstruct the hidden story of the Milky Way's formation. In this way, chemistry becomes a kind of time machine, letting us read a star's past like a line of ancient poetry written in light. The sky is full of stellar streams from shredded galaxies. Across the sky, thin ribbons of stars stretch in arcs and curves, barely visible but unmistakable when mapped with precision. These are stellar streams, the remnants of smaller galaxies that wandered too close to the Milky Way and were pulled apart. As they orbit, their stars are smeared across space by tidal forces, forming long, delicate trails that trace their former paths. Some wrap around the galaxy like ghostly halos. Others dive in toward the core. These streams are evidence of past collisions, quiet mergers that built the Milky Way over billions of years. The galaxy, like a tree, carries the rings of its past in every thread of light. The Milky Way is warped. Our galaxy doesn't lie flat like a perfect spiral. Its disk bends upward on one side and downward on the other, forming a graceful wave across the stars. This subtle warp was invisible to us until radio telescopes mapped the hydrogen gas that stretches far beyond the starlight. Astronomers believe the distortion may be caused by satellite galaxies, tugging gently on the Milky Way's edges, or by clumps of dark matter bending the structure from below. Like ripples in a great spinning sheet, the warp reveals that even galaxies are never fully still. Over time, they bend, flex, and change form in response to invisible forces. From a distance, the Milky Way might look like it's dancing slowly through space. You can only see about 0.0000003% of the Milky Way with the naked eye. Under a clear, dark sky, far from cities and streetlights, you might see a few thousand stars. To the human eye, that seems like an ocean of light, but it's barely a droplet. The Milky Way contains over 100 billion stars. Most are hidden from view. Some lie behind thick curtains of dust. Others are too faint or far away for our vision to reach. The pale streak of the Milky Way that crosses the sky on moonless nights is just the innermost whisper of the whole. We live surrounded by a colossal river of starlight, and yet almost all of it remains invisible to us, too vast to grasp from within. Stars orbit the galaxy at different speeds. Unlike planets in a solar system, which follow neat tracks around their star, stars in the Milky Way move with more freedom. Some race ahead in the inner regions. Others drift slowly along the outskirts. This difference in speed is why spiral arms form. They're not solid structures, but patterns, like slow traffic jams of stars and gas moving through space. As these density waves pass, they trigger new stars to form, lighting up the arms in curls of blue and white. Our own sun is part of this swirl, moving in and out of these patterns across time. The galaxy is not a clock. It is a current, and we are drifting in it. The galaxy holds together because of something we cannot see. By all logic, the Milky Way should not exist. Based on what we can measure, stars, dust, gas, the outer edges of the galaxy are spinning too fast. They should be flung into space, scattered like leaves in a storm. And yet they remain. The answer is dark matter. This mysterious substance does not shine, reflect, or emit any light, but it exerts gravity. and there is so much of it that it outweighs all the visible matter in the galaxy many times over. We don't know what dark matter is, but we know that without it, the Milky Way would fly apart. It is the invisible scaffolding that holds everything in place. There's a supermassive black hole at the core. At the very center of the Milky Way lies an enormous black hole, a singular point of gravity called Sagittarius A*. It is more than 4 million times the mass of the Sun, yet it occupies a space smaller than the orbit of Mercury. We cannot see it directly, but we've watched nearby stars whip around it at tremendous speeds, tracing invisible loops through the void. Sometimes gas and dust fall inward and flare with X-rays as they spiral into the event horizon. For now, Sagittarius A* sleeps, but long ago it may have burned like a quasar, lighting up the galaxy from within. It is the silent conductor of the Milky Way's heart, pulling stars into slow, relentless dance. The Milky Way has a peanut-shaped bulge. When astronomers mapped the center of the galaxy, they discovered something unexpected. The central bulge is not a smooth, round ball of stars, but a three-dimensional peanut shape. Seen from the side, it swells in the middle and narrows at the ends, like a twisting hourglass made of stars. This strange geometry likely formed from the galaxy's central bar, a dense stripe of stars that rotates slowly, buckling and puffing upward over time. These inner structures are sculpted by gravity, billions of years of motion, and the accumulated rhythm of stellar orbits. We live in a spiral galaxy, but its heart is full of complexity, not flat or clean, but intricate and alive. Stellar nurseries shape the spiral arms. The Milky Way's spiral arms are not simply made of stars. They're woven from the birthplaces of stars. Giant clouds of hydrogen, dust, and molecules drift through the galaxy, and when these clouds pass through the spiral arms, they are compressed and set alight with newborn suns. These regions are called stellar nurseries, chaotic, glowing, and full of motion. Ultraviolet light from new stars lights up the clouds, painting the arms with radiant blues and silvers. These bursts of creation trace out the spiral shape, illuminating the curves of the galaxy with quiet fire. Every star, even the Sun, was born from one of these cloudy cradles long ago. The Milky Way is surrounded by a vast halo. Beyond the flat spiral disk lies something far more diffuse, a spherical halo that surrounds the entire galaxy. It contains ancient stars, globular clusters, and enormous amounts of dark matter. Though it is nearly invisible, this halo may hold the majority of the Milky Way's mass. Its stars are spread thin across vast distances, orbiting in long, slow arcs that rarely touch the disk. The halo also preserves the remnants of ancient galactic mergers, streams and shells of stars torn from smaller galaxies and left behind like cosmic fossils. It is the galaxy's outer memory, quiet and dim, but still in motion, still shaping what the Milky Way becomes. It contains over 150 globular clusters. Globular clusters are among the oldest objects in the galaxy, compact spheres made of hundreds of thousands of tightly bound stars. They orbit the galactic center in the halo, like moths circling a distant flame. These clusters are incredibly stable, some more than 12 billion years old, and many contain stars that predate the Milky Way itself. Their stars are metal-poor, meaning they formed before the universe had time to create many of the heavier elements. They serve as time capsules, holding clues to how the galaxy formed, what it consumed, and what conditions were like in the early cosmos. These quiet, golden spheres drift patiently above and below the galactic plane, glowing in the dark. The galaxy is still growing. Although the Milky Way is ancient, it isn't finished. Even now, it continues to gather material. gas from the intergalactic medium, stars from captured dwarf galaxies, and streams of dark matter that feed its halo. It grows not like a living thing, but like a gravitational structure deepening over time. Some of this growth happens quietly, through infilling clouds. Other times, it comes with disruption, as satellite galaxies are torn apart and their stars scattered across the sky. The galaxy you live in today is not the same one the dinosaurs saw, and the one your distant descendants may know could be larger still, stitched from the ruins of 1,000 smaller worlds. Rogue stars are flung from the core. Most stars drift calmly through the galaxy, but a rare few are flung outward at astonishing speeds, fast enough to escape the Milky Way entirely. These are hypervelocity stars. Some are the remnants of binary systems disrupted by the supermassive black hole at the center of the galaxy. One star falls in and vanishes. The other is slingshotted outward, hurled into the dark at over 1 million kilometers per hour. These rogue stars travel alone, far from the galactic plane, like glowing comets with no return. They remind us that even in a galaxy bound by gravity, there are moments of violent release, quiet expulsions that send stars flying into intergalactic night. Star formation is slowing down. Long ago, the Milky Way was more active, bursting with fresh stars born from dense, collapsing clouds. But in recent epochs, the pace has slowed. There is still gas available, but much of it is spread thin, heated, or locked in forms that resist collapse. The galaxy is not done making stars, but it is settling. Astronomers estimate that star formation peaked billions of years ago and has been declining ever since. This does not mean the end is near, only that we live in a quieter chapter. A mature spiral, glowing gently in its middle age, still forming stars, but no longer in a hurry. Some stars formed before the Milky Way had a disk. The disk, the broad, flat spiral we think of as the Milky Way, formed gradually over time. But some of the stars in our galaxy are older than the disk itself. These ancient stars reside mostly in the halo or the thick disk, and they formed when the galaxy was still assembling, a loose cloud of stars, gas, and dark matter slowly collapsing inward. By studying their composition and motion, astronomers can peer back into the era before structure, before spirals. These stars are the elders of the galaxy, silent witnesses to its birth, and the long, slow shaping of what we now call home. A galactic year is about 225 to 250 million Earth years. As the Sun orbits the center of the Milky Way, it completes one full revolution every few 100 million years. This is called a galactic year, a vast cycle of motion that dwarfs all our calendars. In the time it takes for the Sun to circle the galaxy once, continents drift, species rise and fall, and entire epochs unfold. It is thought that we are currently about halfway through one such orbit. The last time the solar system was in this part of its path, the supercontinent Pangaea had just begun to break apart, and dinosaurs had not yet emerged. A galactic year is the slow heartbeat of cosmic time. The Sun has completed fewer than 25 galactic orbits. In all of its 4.6 billion years of existence, the Sun has only circled the Milky Way around 20 times. That's fewer than you might expect, considering its incredible speed, nearly 830,000 kilometers per hour. But the galaxy is so vast, and the Sun's path so long, that each orbit takes hundreds of millions of years. We often think of the stars as ancient and unmoving, but our solar system is still young on a galactic scale, a newcomer in a city of older, more traveled suns. We are part of the galaxy's motion, but still early in its long, winding story. The Milky Way's rotation defies Newton's predictions. According to Newtonian physics, stars farther from the galactic center should orbit more slowly, just as outer planets move more leisurely around the Sun. But in the Milky Way, stars in the outer regions orbit almost as quickly as those near the center. This defies classical expectations. The reason, astronomers believe, is dark matter, an invisible, unknown form of mass that surrounds the galaxy in a vast halo. Without dark matter, the galaxy would not hold together. With it, the math works. The Milky Way turns like a solid wheel, not because we understand it fully, but because something unseen is holding it in place. The galaxy has enormous molecular clouds. Scattered throughout the Milky Way are vast dark clouds of cold gas, the raw material of stars. These molecular clouds, composed mostly of hydrogen molecules and traces of dust, can span hundreds of light years across. Within their cold, dense interiors, gravity begins to gather material, forming clumps that collapse into new stars and planets. Some of these clouds are so large and so cold that they absorb visible light entirely, appearing as black patches against the starry sky. They are the galaxy's wombs, quiet, hidden places where the future begins in silence, tucked within curtains of shadow and gas. Supernovae stir the galaxy like storms. When massive stars reach the end of their lives, they explode in cataclysmic supernova, events so powerful they can outshine entire galaxies for a brief moment. These explosions don't just end lives, they create. Shockwaves from supernova ripple through the interstellar medium, compressing nearby clouds and triggering new waves of star formation. They enrich the surrounding space with heavy elements like iron and gold, forged in the heart of the dying star. In this way, supernova act like storms within the galactic ecosystem, stirring, fertilizing, and reshaping everything around them. They are the galaxy's moments of chaos, destructive, radiant, and necessary. Dust hides vast regions of star formation. The Milky Way is full of light we cannot see. Interstellar dust, made of microscopic grains of carbon, silicates, and ice, weaves through the galaxy in clouds and tendrils. In visible light, it obscures vast regions of space, blotting out stars and entire nebulae. But behind this veil, star formation continues. Infrared telescopes can peer through the dust, revealing glittering nurseries filled with newborn suns. What looks like darkness is often a cradle. The dust, though it hides, is part of the process, absorbing energy, helping gas cool, and shielding delicate stages of stellar birth. What seems like emptiness is often the beginning of something bright. There are starless gas clouds drifting through the galaxy. Not every cloud of gas becomes a star. Across the Milky Way, astronomers have found massive cold clouds that seem destined for collapse, yet remain dark and dormant. Some are too diffuse. Others may be stabilized by magnetic fields or internal turbulence. These starless clouds float through the galaxy like silent possibilities, rich in molecular hydrogen, but untouched by fusion. They may one day ignite, or they may drift until torn apart by external forces, their gas recycled into other regions. In these clouds, the galaxy holds its breath, waiting, perhaps, for the right nudge to spark something new. The Milky Way recycles matter across generations. Stars are not permanent. They live, burn, and die. And in dying, they return their material to the galaxy. Supernovae spread heavy elements. Red giants shed outer layers. Planetary nebulae drift outward into space. This enriched material joins the interstellar medium, where it cools, condenses, and eventually forms new stars, planets, and even life. Every atom in your body has passed through this cycle, born in a star, scattered into space, gathered into new form. The Milky Way is not a static stage, but a great engine of renewal. It breathes in time with its stars, making